previous video class we have saw introduction of properties of modulus of complex numbers and 3 sums in exercise 2.5. Now we are going to solve fourth sum in exercise 2.5. So we will enter the fourth sum. If modulus of z is equal to 3, solution modulus of z is equal to 3, show that 7 less than or equal to modulus of z plus 6 minus 8i less than or equal to 13. So given is nothing but modulus of z is equal to 3. To prove, what I need to prove? 7 less than or equal to modulus of z plus 6 minus 8i less than or equal to 13. How we can solve this sum? Very easily. For this sum we need two formulas, two properties. The first property is nothing but modulus of z1 plus z2 is less than or equal to modulus of z1 plus modulus of z2. This is the first we have saw triangle inequality property. Another formula, modulus of z1 minus z2 is greater or equal to whole modulus of z1 minus z2, modulus of z1 and minus z2. These two properties write always in the right hand side of the corner of the question. Once if you are going to get this question in exam, first write these two properties, then only you can easily answer this sum. So I am going to take this one, z plus 6 minus 8i. I am going to take modulus of z plus 6 minus 8i. First I am going to take this one. This I am going to divide into two parts. Listen carefully. z1 plus z2, z1 minus z2. This one I am going to consider as z1. Listen very carefully. This one I am going to consider z1. This one, the whole 6 minus 8i, I am going to consider z2. z1 and z2. This one I am going to consider z1 and this one I am going to consider z2. See, the first formula is z1 plus z2, no problem. What is z1? z1 plus z2. See, z1 is z, z2 is 6 minus 8i, no problem. What is second formula? z1 minus z2. z1, there is no minus is present here. So I am going to separate this one into two ways. What is first way? The first way is nothing but modulus of z1 plus z2. What is second way? Modulus of z1 minus z2. See, modulus z1 plus z2. So this way can be written as it is. See, z1. What is z1 here? Z plus z2 6 minus 8i. You can have this is z1 plus z2. If you are going to see z1, what is z1 here? Z minus, I need to put minus, so minus. So since minus comes here, in 6 minus 8i I am going to take minus outside, so it becomes minus 6 plus 8i, close the modulus. This is the main thing you need to learn here. So only I am separating here. This one is in this formula plus is present, here plus is present. In this formula minus is present, but minus is not present. If we are going to take minus outside, then it's become minus 6 plus 8i. Minus 6 plus 8i. Going to take minus outside. If we are going to take, I need to take 6 minus 8i. I am going to take minus. We are going to take minus outside. This plus 6 will become minus 6. Minus 8 become plus 8i. Now see, this is z1 plus z2. This is z1 minus z2. Now I can apply the formula. How I can apply the formula? See, less than or equal to modulus of z1. This is z1, no? So modulus of z plus modulus of z2. This is z2, no? This will be z1. This will be z2 plus modulus z2. 6 minus 8i less than or equal to. What is the modulus of z given here? 3 plus, real square plus imaginary square. 6 square is 36 plus imaginary is minus 8. Minus 8 the whole square is 64. Less than or equal to 3 plus 36 plus 64 is 100. Square root of 100 is nothing but 10. Less than or equal to 13. See, we have got one answer, less than or equal to 13. The same procedure, but here greater or equal to. Listen carefully, greater to. Whole modulus. First put whole modulus. Modulus of z1. This will be z1. This will be z2. Whole modulus of z minus minus 6 minus 8i, minus 6 minus 8i greater or equal to whole modulus. What is modulus of z? 3 minus square root of real square is minus 6. Minus 6 the whole square, 36. Real square plus minus 6 plus 18. Imaginary square, 8 the whole square, 64. Listen carefully, greater or equal to 3 minus. This is square root of 100. Square root of 100 is 10. Greater or equal to 3 minus 10 minus 7. Greater or equal to 7. Minus 1 become plus 7. See here, I got 7, I got 13. Keep this equation 1, keep it as equation 2. Combining 1 and 2. Combining 1 and 2. Combine 1 and 2. How I can write this question as it is. That's all. 7, see, 7 less than or equal to modulus of z plus 6 minus 8i less than or equal to 13. Hence proved. That's all. This sum we can prove in this method, no problem. So this is the main concept is here plus no problem. But minus comes, there is no minus here. So in this I want to take minus outside. This is the main concept. I need to take once a minus I taken outside, the sum will be very easy. So next we move towards fifth sum. Fifth sum, if modulus of z is equal to 1, then show that 2 less than or equal to modulus of z square minus 3 less than or equal to 4. This is one of the same sum, one of the important sum. We can do this sum as we need, like the previous method. First we need to write two properties. What is the first property? Modulus of z1 plus z2 is less than or equal to modulus of z1 plus modulus of z2. The next formula is nothing but modulus of z1 minus z2 is greater or equal to whole modulus of z1 minus z2. So now we can start our answer. So we are going to take this one alone. So modulus of z square minus 3. This one I need to divide in two parts. See, minus percent, so no problem here. Z1 minus Z2. So this one we achieved here. Z square minus 3 we achieved, no problem. So because this is Z1, this is Z2. But here plus I need to come Z1 plus Z2. So modulus of Z square plus I will put bracket in minus 3. That's all. Because plus into minus, minus Z1 plus Z2. Z1 plus Z2. So this will become Z1 and this will become Z2. That's all. Now applying formula. Less than or equal to modulus of Z2. Modulus of Z1. Z1 is this one. Z square plus modulus of Z2. Modulus of Z2 is nothing but minus 3. Z2. This Z2 is minus 3. Less than or equal to modulus Z square. Modulus of Z is 1. We know modulus of Z is 1. Modulus of Z square is nothing but 1 square. 1 square is also 1. So 1 plus modulus of minus 3 become plus 3. Less than or equal to 4. We got one answer. See very how easily we have got the answer. This one is greater or equal to whole modulus. This is modulus of Z square minus modulus of Z2. Nothing but Z square minus minus. So minus minus 3. So greater or equal to modulus Z square is nothing but 1 minus 3. Equal to 1 minus 3 is minus 2. Minus will become plus 2. So keep this equation 1, keep this equation 2, combining 1 and 2. Combining 1 and 2 we get, first write this one and this one and this one. So if you want you can see the question right. 2 less than or equal to modulus of Z square minus 3 less than or equal to 4. Hence proved. Very easy sum. Fourth sum, fifth sum are same model. Still there is one example sum. This model also you can do in this method. The sum will become very easy. The main concept is plus should be present, minus should be present, because plus and minus, then only we can apply the formula. This is the main concept. Sixth sum, very important sum. Modulus of z minus 2 by z is equal to 2. This is given. First given. Write given first. Modulus of z minus 2 by z. 2 by z is equal to 2. Show that. To show. To show is nothing but to prove. What I want to prove? The greatest and least value of modulus of z. Therefore, greatest and least value of modulus of z is root 3 plus 1, square root of 3 plus 1 and square root of 3 minus 1. This is the greatest value of modulus of z. This is the least values of modulus of I need to prove. For this proveness, I need to first write a property. First, this well-known property in the previous sum, modulus of z1 minus z2 is greater or equal to modulus of z1 minus z2. The whole modulus. This property is well known. So using this property, I can use. First, I am going to take this one alone. This one. Consider. First, consider. What I need to consider? Modulus of z minus 2 by z. 2 by z. So apply the above property here. Greater or equal to z1. Here z is nothing but z1 and z2 is nothing but 2 by z. Apply greater or equal to whole modulus. Whole modulus of z1. Z1 is nothing but z minus modulus of 2 by z. Modulus of 2 by z. Now greater or equal to value. This value is nothing but 2. So given here, modulus of z minus 2 by z is equal to 2. This value is nothing but 2. Greater or equal to whole modulus of z minus. What is modulus of 2? 2. 2 divided by modulus of z. So next, what we can do? Next, I am going to remove this modulus. If we know one property, nothing but modulus of z less than 2, we can write as minus 2 less than x less than 2. Listen very carefully. This modulus of x I can write as x. This 2 I can write as minus 2 to 2. Minus 2 and 2. The same property, but here 2 is present. So I need to interchange this property. How I am going to do is nothing but minus 2 less than or equal to modulus of z minus 2 divided by modulus of z less than or equal to plus 2, because minus 2 is less than 2. I need to interchange the inequality symbol. Minus 2 is less than 2. So this whole modulus is removed. Remove the whole modulus, I put minus 2 to 2. Minus 2 to 2. Now this modulus and can be cross multiplied. So minus 2 less than or equal to modulus of z into modulus of z, I can write as modulus z the whole square minus 2 divided by modulus z less than or equal to 2. Less than or equal to 2. Now this modulus moves this side and this side also. So after moving this modulus, how I can write? Minus 2 modulus of z less than or equal to modulus of z square minus 2 less than or equal to modulus moves this side 2 into modulus of z. This part can be divided two ways. What is the first way? The first way is nothing but minus 2 modulus of z less than or equal to this part alone. This is the first part. Modulus of z square minus 2. The second part is from here to here. How it is going to be? Modulus of z square minus 2 less than or equal to 2 into modulus of z. That's all. So this minus 2 modulus z comes this side. So 0. If it comes there, becomes 0. Less than or equal to modulus z square. This minus comes, this becomes plus 2 into modulus z minus 2. The same. This one comes here. So modulus of z square minus, this becomes plus 2 modulus of z comes, this becomes minus 2 modulus of z, this minus 2 less than or equal to 0. So now using completing square method, so 0 less than or equal to modulus of z square plus 2 modulus of z, I need to write, because minus 2 no, so plus 1 square minus 1 square and minus 2, plus 1 square and minus 1 square and minus 2. The same way also modulus of z square minus 2 modulus z, because here minus is present, minus 2 modulus z, how I can write? Plus 1 square minus 1 square minus 2 less than or equal to 0. So this is plus 1 square minus 1 square, same plus 1 square minus 1 square. This one I can write as 0 less than or equal to a square plus 2a, I can put 1, no problem, 1 plus b square. So this will becomes modulus of a square plus 2ab plus b square. A square plus 2ab plus b square. I can written as, see, this is modulus of z. Modulus of z plus 1 whole square, a plus b the whole square, a square plus 2ab plus b square. 1 square is 1, 1 minus 2 is minus 3. 1 minus 2 is minus 3. The same is also from here to here. Now I can write modulus of z minus 1. This is minus 2, no? This is plus 2 plus 1. This is minus 1. Minus 1 the whole square. Minus 1 the whole square, nothing but minus 3 is less than or equal to 0. So this one I can write it. This minus 3 come this side becomes plus 3. Plus 3 is greater or equal to modulus of z plus 1 whole square. Next, this square comes, it becomes square root of 3. Square root of 3 greater or equal to modulus of z plus 1. Plus 1 comes, this becomes square root of 3 minus 1 greater less than or equal to modulus of z. So I am going to interchange this inequality symbol. I can write as greater or equal to this modulus z comes this side. This root 3 minus 1 moves this side. So modulus of z is greater or equal to 3 minus 1. Greater or equal to 3 minus 1. But check it here. The same. Minus 3 move this side becomes plus 3. Less than or equal to plus 3. Modulus of z minus 1 the whole square. Square comes this side becomes square root of 3. Modulus of z minus 1. Minus 1 on this side becomes plus 1. Square root of 3 plus 1 nothing but modulus of z. Modulus of z is less than root 3 plus 1. Suppose if we are going to combine this, keep this equation 1, equation 2, combine 1 and 2. If I am going to combine 1 and 2, what are going to answer? Modulus of z, modulus of z, modulus of z, root 3 minus 1, root 3 minus 1 less than or equal to root 3 plus 1. Modulus of z value is greater than root 3 minus 1 but less than root 3 plus 1. Therefore, from this we can write least value. Least value of modulus of z is root 3 minus 1 and greatest value of modulus of z is root 3 plus 1. Seventh sum, very important sum. Z1, Z2 are three complex numbers such that given modulus of Z1 is equal to 1, modulus of Z2 is equal to 2 and modulus of Z3 is equal to 3. First, for this one, what I am going to do, squaring on both sides for each and everything. Squaring on both sides. Squaring on both sides. So, modulus of Z1 square. Modulus of Z1 square is equal to 1 square. Modulus of Z1 square is equal to 1 square. Modulus of Z2 square is equal to 2 square. And modulus of Z3 square is equal to 3 square. Modulus of Z1 square, 1 square is 1. Modulus of Z2 square, 2 square is 4. Modulus of Z3 square, 3 square is 9. We know one formula. What is the formula? Modulus of Z square is equal to Z bar. Modulus of Z square is equal to Z bar. Modulus Z1 square is nothing but Z1 bar is equal to 1. The same here also. Z2 bar is equal to 4. Z3 bar is equal to 9. Z3 bar is equal to 9. Therefore, Z1 I can write as 1 by Z1 bar. Next, Z2 I can write as 4 by Z2 bar comes down. Z2 bar. Z3 is nothing but 9 by Z3 bar. So, this one is very useful to solve this sum, to apply our derivation to prove. Next, what I need to prove? Modulus of 9 Z1 Z2 plus 4 Z1 Z3 plus Z2 Z3 is equal to 6. I am going to take LHS alone, taking LHS. So, LHS. What is LHS? Modulus of 9 Z1 Z2 plus 4 Z1 Z3 plus Z2 Z3 is equal to modulus Z1 Z2 Z3 divided by Z1 Z2 Z3, open the bracket, 9 Z1 Z2 plus 4 Z1 Z3 plus Z2, Z3, close the modulus. What I have done in inside the modulus, multiplying and dividing by Z1, Z2 and Z3. Multiplying and dividing by Z1, Z2 and Z3. So is equal to modulus Z1, Z2, Z3. This will remains as it is here. This one divides each and every one. 9 divided by Z1, Z2 cancels, Z1, Z2 cancels, remaining Z3 plus 4. Z1, Z3 cancel, Z1, Z3 cancel, remaining Z2 plus 1 divided by Z2, Z3 cancels, remaining Z1. Close the modulus. So, listen carefully. Modulus of Z1, Z2, Z3, 9 by Z3. What is 9 by Z3? Is nothing but Z3 bar. In spite of writing, I have done one small identification. In spite of writing, I can done one here. What I do? I need 9 by Z3. 9. This Z3 can come down. So 9 by Z3. 9 by Z3 is nothing but Z3 bar. Z3 bar plus 4 by Z2. 4 by this Z2 comes here. Z2 bar moves here. 4 by Z2 is nothing but Z2 bar plus 1 by Z1 is nothing but Z1 bar. I will change now here. Therefore, Z3 bar is equal to 9 by Z3. Z2 bar is equal to 4 by Z2. Z1 bar is equal to 1 by Z. What we need, we can adjust and write. Okay, we can adjust and write. Now we written Z3 bar plus Z2 bar plus Z1 bar. So, I am going to remove the modulus for each and every one. Modulus of Z1, modulus of Z2 and modulus Z3. Modulus Z1, Z2, Z3. For this one, old modulus. Old modulus I can write Z1 plus Z2 plus Z3 whole bar, because we know one property. What is the property? Z1 plus Z2 whole bar I can write as Z1 bar plus Z2 bar. Same, Z1 plus Z2 plus Z3 whole bar I can write as Z1 bar plus Z2 bar plus Z3 bar. Separate bars I can write the whole bar. Separate bars I can write the whole bar. We know another property. Modulus of Z is equal to modulus of Z bar. In modulus Z bar is nothing but Z. Say same. Modulus of Z1, modulus of Z2, modulus Z3. In modulus this bar is equal to Z. So don't need bar itself. Z1, Z2 and Z3. So what is modulus of Z1? Modulus of Z1, answer is given for us in first it's a modulus of Z1 in question 1, modulus of Z2 is 2, modulus of Z3 is 1, modulus of Z3 is 1, modulus of Z1 plus Z3 is nothing but 1. So final answer is 6, is nothing but RHS N's proved. Eighth sum, very easiest sum, but one of the important sum. I am not going to explain first. I am going to apply the formula. I am going to tell. If the area of a triangle formula. So area of a triangle, you know formula. You can take 1 by 2 base into height of vertices are Z, IZ and Z plus IZ. They are given 3 vertices. First vertex is Z, second vertex is IZ and third vertex is Z plus IZ. Nothing but adding first and second vertices, which gives third vertices. So I am going to take this one as base, this one as height, no problem, base and height. They given area is nothing but 50. So area of a triangle is nothing but 50 is equal to 1 by 2. Base is nothing but base is nothing but Z, but I need the length. So length is nothing but modulus of Z. So modulus of Z, length or distance, modulus of Z. This one is modulus of IZ. You should not put Z and IZ because Z is a point, vertices. But I need base, no. Base is nothing but length. I need length of length. That is the distance of the base, length, measurement. So only we using the modulus. So 2 goes here, nothing but 52s are 100. modulus of z. I can separate the modulus. Modulus of I into modulus of z. You know, modulus of I, nothing but 1 square is nothing but real square plus imaginary square. Actually, it's nothing but real square plus imaginary square. Imaginary square. Real square is absent. Imaginary quotient is 1. 1 square is 1. So, modulus of I value is 1. So, 100 is equal to modulus of z into modulus of z is nothing but modulus of z square. I value is nothing but 1. Square comes this side becomes square root. Otherwise, 100 is nothing but 10 square. 10 square is nothing but modulus of z square. 10 square is nothing modulus of z square. So, we need modulus z value. Therefore, modulus of z is nothing but 10. We are finished. But only one question for you. Why we are not chosen this value, third vertices. I am going to give explanation for this. So, there are three vertices z, iz, z plus iz. Now I am drawing a real and imaginary. Listen very carefully. So I am going to choose this as z point. This is z point. This is z. So this is a distance from origin to z. So I need to put mod of z. This is a length. Length is nothing but distance. So only use modulus. I am going to choose iz here. This can be iz. So this distance nothing but modulus of iz, length from origin to point iz, distance. So how I can find distance between both the points. So for this line I need to draw another parallel line. I draw another parallel line. So if this is model of z, this is also model of z. For this line, I am going to draw another parallel line. So this is another parallel line. So this is modulus of iz means this is also modulus of iz. I have drawn. Now I need to form a triangle. This is a resultant. Wherever you can form, no problem. So from here to here I will draw. From here to here I will draw because this is z point, this is iz point. So the distance of z and iz is nothing but modulus of z plus iz. This is the z plus iz. Otherwise, no, sorry, not this one. Sorry, students. This one. This point is nothing but z plus iz. So this distance nothing but z plus iz. Sorry for this. This is z plus iz. This is z plus iz. Okay. This z plus iz. This is nothing but z plus iz. So if I am going to take this one, this triangle, this part triangle, this I am going to take this triangle. This is z plus iz. This point is origin O, leave it as it is. This point is z. So what is that? This length is nothing but modulus of z. This is nothing but modulus of z plus iz. This is nothing but modulus of iz. So this is form a right angle triangle. So this is hypotenuse, this is opposite, this is adjacent, nothing but base and height. You can take this one as base and height. Base and height. Okay, so this is iz and z. Iz and z. Iz and z is nothing but base and height. So you don't need to explain this all. Just why I am not choosing z plus iz. I am choosing base and height this one because this is because of the length, the breadth and height. That's all. Very, very important sum. The ninth sum. Show that the equation z cube plus 2 z bar is equal to 0 has 5 solutions. I need to show this equation has 5 solutions. So I am going to show how. First write z cube plus 2 z bar is equal to 0. Z cube plus 2 z bar is equal to 0. Z cube, if 2 z bar goes this way, becomes minus 2 z bar. Okay, minus 2 z bar. So taking modulus of z cube is equal to modulus of minus 2 z bar. This power I can write outside, z modulus of z cube using a formula, power outside, minus modulus of minus 2 modulus of z bar, modulus of z cube, modulus of minus 2 become 2 modulus of z bar. We know formula in modulus, while in modulus the bar we can write as like this, no problem. Without bar we can write 2 modulus z. Now let move this side. Modulus of z cube minus 2 modulus of z is equal to 0. Now what is common here? Modulus of z is common. After taking modulus of z, here what it becomes? Modulus of z square minus 2 is equal to 0. I taken modulus of z is common. So z modulus of z square minus 2 is 0. Now equate to 0. This one equate to 0. This one also equate to 0. So what it becomes? Modulus of z is equal to 0. One solution. This is one solution. This is one part. Still I need to show 4 solutions. Equate this one. Modulus of z square minus 2 is equal to 0. Modulus z square minus 2 is equal to 0. Now what I want to do? Modulus of z square minus 2 becomes plus 2. We know one formula. Modulus of z square is nothing but z bar. So modulus is nothing but z bar is equal to 2. From this we can divide in 2 ways. Z is equal to 2 by z bar, or z bar is equal to 2 by z. Which one we can able to use? That one we can take. From this, z is equal to 2 by z bar, or z bar is equal to 2 by z. Z bar is equal to 2 by z. Now what you going to do is nothing but, so keep it as it is. Keep it as it is. Now take the given equation for us. Given equation is nothing but given equation. What is given equation? Z cube plus 2 z bar is equal to 0. Z cube plus 2 z bar is equal to 0. Keep z cube as it is plus 2. What is z bar? We need this one only. Z bar is nothing but 2 by z is equal to 0. Now cross multiply. Z into z cube is nothing but z power 4. Z power 4. 2 2s are 4. Whole divided by z is equal to 0. Let z moves this side. So it becomes 0. If z moves, it becomes z power 4 plus 4. Z into 0 is 0. This is power 4, no? It has 4 solutions. 4 solutions. Why it has 4 solutions? Because z power 4. Z power 4 means 4 solutions. So here one solution, here one solution, here 4 solutions. Totally we have 5 solutions. Therefore z cube plus 2 z bar has 5 solutions. That's all. The last sum in this exercise, find the square root of 3 subdivisions. First formula we write. The first formula is, you can write square root of a plus ib. Square root of a plus ib is nothing but, you can write square root of z also, no problem. Square root of z. Square root of z is nothing but square root of a plus ib. Otherwise you can write modulus of z. This modulus only going to put square root, so no problem. So is equal to plus or minus, open the bracket, listen carefully, square root of modulus of z plus a divided by 2 plus I b divided by modulus of b square root of modulus of z minus a divided by 2, where b should not equal to 0. If it is 0, it becomes infinity. So only take the first subdivision. First subdivision is 4 plus 3i. The first subdivision 4 plus 3i. Find the square root. So I need to use square root. Find the square root. So compare here. What is a? A is nothing but 4. B is nothing but 3. A is 4. B is 3. So next I need to find. You can take this one as square root of z. Square root of z. So square root of z. Square root of z. I need to put square root of 4 plus 3i. Nothing but I can use modulus. Square root of z is nothing but 4 square. 4 square plus 3 square. 4 square plus 3 square is nothing but, what is 4 square? 16. 3 square is 9. Square root of 25, which gives 5. A is 4. B is 3. We have modulus of b. Modulus of b is also, modulus of 3 is also 3 only. Square root of z. This is z, no. Z is nothing but 4 plus 3i. Square root of z. If you want to take, I will explain here. Z you can take as 4 plus 3i. What will be modulus of z? Modulus of z is nothing but modulus of 4 plus 3i. Nothing but 4 square, real square plus imaginary square. nothing but 5. Here only, that only I am putting here. No problem. Now I can apply. Square root of 4 plus 3i is equal to plus or minus, open the bracket, square root of modulus of z. Modulus z is nothing but 5 plus a. A is 4. Divide by 2 plus I. B is 3. Modulus of b is also 3. Square root of 5 minus 4 by 2. So final answer is nothing but plus or minus square root of 5 plus 4, 9. Square root of 9 by 2. 5 plus 4 is 9, no. Square root of 9 by 2 plus I. 3 gets cancelled. 1 by 2. So plus or minus square root of 9 is 3. 3 by square root of 2. I need to write square root of 2 as it is. Square root of 2 plus I. Square root of 1 is 1. Divide by root 2. So we can stop here itself, no problem. Otherwise, you can make only one square. So this is enough. Second subdivision, square root of minus 6 plus 8i. First write formula. What is the formula? Square root of a plus ib is equal to plus or minus square root of modulus of z plus a by 2 plus I. B divided by modulus of b, square root of modulus of z minus a by 2, where b is not equal to 0. Here a is nothing but minus 6, b is equal to 8. Next I need modulus of b. Modulus of b is also 8. Next z is minus 6 plus 8i, which shows modulus of z. I need modulus z, no. Modulus of minus 6 plus 8i, square root of minus 6 the whole square, 36, 8s are 64, square root of 100, which gives 10. Now apply here. Square root of minus 6 plus 8i is equal to plus or minus, open the bracket, square root of modulus of z is 10 plus a is minus 6, 10 minus 6 divide by 2 plus I. B is 8 divide by modulus of b. Modulus of b is also 8 because modulus of 8 is once again 8. So square root of 10, here already minus, here minus into minus plus, so plus 6 by 2. So plus or minus 10 minus 6. What is 10 minus 6? 10 minus 6 nothing but 4. Square root of 4 by 2 plus 8 gets cancelled. I. Square root of 16 by 2. Square root of 16 by 2. So plus or minus 4 and 2 cancel. So I go get a square root of 2 plus 16 and 2 gets cancelled. I get square root of 8. This square root of 8 I can write square root of 4 into 2. Square root of 4 is nothing but 2. 2 into square root of 2, nothing but plus or minus square root of 2 plus I. Square root of 8 I can add as 2 into root 2. So this is the second subdivision. Next I am going to write the final third subdivision. Third subdivision is minus 5 minus 12i square root. First write the formula. Square root of a plus ib formula is equal to plus or minus square root of modulus of z plus a by 2 plus ib divided by modulus of b, square root of modulus of z minus a by 2, comma b is not equal to 0. A is minus 5. B is minus 12. A is minus 5. B is minus 12. Next I need to find modulus of b. Modulus of b is equal to modulus of minus 12. Modulus of minus 12 is plus 12 only. Because b is minus 12, modulus of b is minus 12, nothing but plus 12. So next modulus of z is nothing but modulus of minus 5 minus 12i. So square root of minus 5 the whole square 25, 12 the whole square 44, square root of 169, which gives 13. Real square plus imaginary square. Now I can apply the formula. Square root of minus 5 to 12i is equal to plus or minus, open the bracket, square root of modulus of z. Modulus of z is 13. A answer is minus 5 divided by 2 plus b is minus 12. Minus 12. Modulus of b is plus 12. Plus 12 square root of 13. Here minus become plus. 13 by 5 divided by 2. So plus minus 13 minus 5, square root of 8 by 2. This will become 12 cancel, plus into minus is minus. 13 plus 5, 18, square root of 18 by 2. 13 plus 5, square root of 18 by 2 is equal to plus or minus. 8 and 4 cancel, square root of 4 minus 8 and square root of 9. Here I have missed I here. Sorry students, I have missed I here. I, square root of 9. So final answer plus or minus square root of 4. Square root of 4 is 2 minus square root of 9 is 3i. So this is the final answer. Within this we are finishing the exercise 2.5.